Okay, we're going to go over the crank, fuel and timing, and airflow tab just to kind of walk through the basic procedures and what these tables do and the functionality of each tables. But before we get started, it's important to understand the different states the engine can be in and how ProEFI determines those states. So we're going to click on the Advanced Setup tab for just a second. And then in here, you're going to see crank to run RPM, crank to stall RPM, run to stall RPM, and stall to crank RPM. This is going to define the different states. So you have stall is one state, cranking is a state, and then run is a state. So if I start spinning the starter and get the engine moving, we're going to be running a crank to run RPM up till 800. So at first glance, this might seem a little bit high, but your starter's probably spinning 150 to 200 RPM. So this is basically saying I'm going to get cranking and fueling information from the crank tab until I exceed 800 RPM. Once it exceeds 800 RPM, it's going to switch into the run mode as long as it's seen this many TDC counts. Okay, so it's going to sync as long as it's seen at least 2 syncs while the engine's firing. Then it's going to go into the run mode as long as this value is exceeded. So I like to leave that number a little bit higher, just so it has to go above that, and then it has to drop down below this to go back into crank fueling. So you're going to be in the run mode once it fires. And when the engine fires, typically you're going to get over 800 RPM, and then it's going to settle down to whatever your idle speed is. So this makes the transition a little smoother. Then when you hit the key off, it's going to go run to stall once it goes below 100. So you're staying in run down to 100 RPM. Okay. Once you drop below 50, it's going to go to stall. So you'd have 50 RPM between 100 and 50 where we're going back into crank, but obviously we're not trying to refire the car if the key's off. It's just going to turn off anyways. So now let's go back into the crank warm-up tab. Okay, we've got these different parameters here that you can look at to help aid in starting the car. The most important ones to pay attention to are obviously things like fuel pressure, battery voltage. Make sure those things, you have adequate amount of those things there. But the encoder fault count and the engine sync state. The engine sync state is going to stay at 0 speed until it sees rotating assembly moving. So cam and crank information coming in. All right. Once the cam and crank information comes in, it should say encoder sync, cam sync right here. You may get 1, 2, maybe 3 or 4 encoder fault counts. That's normal under cranking. Once it's in the run mode though, whatever value this is should stay there. If you're running the engine on the dyno or revving it up and you're getting increasing fault counts, that means that the computer's losing the engine position for some reason. You're getting inadequate information from your cam or crank sensors. So then you want to diagnose those in one of the other sync windows. But for now, we're just dealing with just the crank warm-up table. But that's where you get this information from. Okay, so the first things that we want to look at is airflow. When you're trying to start the car, if it's hard to start and you give it throttle, for example, and the engine wants to fire, then that means you've got too much fuel or not enough air. That's addressed here, the crank airflow set point %. Okay, on electronic throttle applications, this is throttle opening value. On idle air applications that are manual throttle body, this is idle air bypass. It's important to remember that, especially if you're starting from a calibration that had one or the other, because this is not going to be enough idle air bypass, but it's a proper amount for electronic throttle. Consequently, if we had idle air bypass in here, we'd have numbers of 50 to 100%. That'd be bad on electronic throttle because we're going to be opening the throttle way too much. Okay, so in that example of having to add throttle to get the car to fire, we can add that idle air bypass here, or we can address the amount of fueling that's given over here, which is by temperature and RPM. So again, if we're giving it throttle to get the engine to start, we may need to lower the amount of fueling that we're getting. If we have an adequate amount of air supply, but it doesn't want to fire, that means we're over fueling the engine, so we're going to lower those values here. Okay, these blend together based on ethanol content. So this is the values you get from flex fuel at 100% ethanol, or whatever value you have it going to 100% authority from this table in your blend table. And this is what you get on gasoline. So in this particular case, we're giving it 100% authority at 50% and higher is reading out of this table. Below that, it's blending at this rate. So for example, if we're on this site right here at a 50%, that means whatever value we have here, whatever value we have here, you're splitting the difference. You're getting halfway between the two tables. Okay? So it's important to understand how that works and which table you're going to need to address If you've got it firing fine on pure gasoline, you put ethanol in there and it's not starting, you leave this table alone and you address this table here. Okay, crank spark advance, just ignition timing based on RPM. If you have a real high compression engine, these numbers are going to be pretty low at low engine speed and then ramping up, may even be negative depending on how much compression you have and how fast the engine wants to start. The faster it starts, the lower these numbers need to be, because you may not be at 100 or 200 RPM when it sinks and tries to fire. So if you're getting kickbacks, lower these numbers at the lower speeds, maybe even at higher speeds too, just depending on what situation you're running into. Our options over here: crank fuel blend from flex fuel, yes or no. That turns this functionality on over here. If you have no there, everything's red from the gas cranking table. Yes, it's going to look at this blend and determine what's going to happen here. Clear flood throttle threshold, 80%. That means if I'm at over 80% throttle, it's going to turn the injectors off and just spin the engine over to try and clear the flood condition. Cranking throttle scalar of 1. I typically leave this at 1. This just means as you're increasing throttle, you're going to increase fuel at the normal 1-to-1 rate. Okay, so that way it's easy to determine if you're giving it more air to help the engine fire or not. Like I said, I never really have to adjust this, but if you want to, you can give it more or give it less depending on what situation you're running into. Stall mode starting throttle, 13% in this example. In the stall mode on electronic throttle, this does not apply to idle air, it's going to have the throttle sitting at 13%. So when you go into crank, it's going to go right to this table to 22%. So this is you can use this value to help choke the engine when you go into starting. I typically will leave this somewhere halfway between this value and 0 is fine. You can leave this at 0. It just depends on what the engine wants and needs to get it to fire. Use APP at stall. I typically leave this to yes on electronic throttle. It doesn't have anything to do with the manual throttle, but on electronic throttle, leave this at yes. Allows you to calibrate the throttle without the engine running. Okay, then we come into the warm-up after start enrichment table. This table does two things. It does warm-up based on time since run, and then it does warm-up based on temperature. So against run time is your horizontal axis. So based on whatever temperature you're going to fire it up, it's going to be that much multiplier until it gets to this amount of time. Then it stays there until it warms up and gets down to your warm-up number. Your warmed up number should always be a 1. If you have a higher or lower value over 1 in there, it's going to add that percentage to fuel all the time. It's never going to come out. So you always want to make sure that this last value there is a 1. Okay. Cranking start of injection. This is just injector phasing during cranking. You can adjust that up or down. With these numbers are pretty much I leave in everything. It doesn't make too much difference, but if you really want to play with it, you can. You'll notice this table says offline. So other than the 112 and the Pro Mod and dealer boxes, you have to make these changes offline and flash them back in. All these other tables are live, fully calibratable live. So anything you need the engine running to do is typically always set up to be run live. Okay. You also have a cranking help in the top corner that'll open a PDF that explains all of these tables. You can also right click on the table, go to help, and it will give you an explanation of what that table does there. And in your options in the bottom right hand corner, you can click and hit help, and it will give you a description of that particular option right there as well. So there's plenty of help on how to do this stuff. Hopefully this video will help you out in getting your cranking fuel and timing adjusted in a way that the engine starts nice and crisp for you.